Okay, so for numbers 1 through 4, you have to sketch the graph, state the domain and range, and the end behavior of each function. So x to the 7th, when you plug it into Desmos, or just if you figured out the pattern, you don't even have to do that. You know that it's going to look something like this. The domain is all reals, and the range is also all reals because it goes from top to bottom, never ending, no gaps in the graph. The end behavior is as x goes to infinity, f of x goes to infinity, and as x goes to negative infinity, f of x goes to negative infinity. You could also describe it as down up because the left side goes down and the right side goes up. Okay, number 2, f of x equals negative x to the 9th. Well, this is an odd degree polynomial with a negative a. So it's going to do the opposite of what number 1 did. It's going to go like this, like this. Okay, the domain is still all reals. Oops. And the range is all reals because, again, there's no gaps. It goes top to bottom, no gaps, so it covers all the y's. And then the domain, the end behavior as x goes to infinity, f of x goes to negative infinity, so that means that on the right side it goes down. And as x goes to the left, smaller and smaller, f of x goes up. Okay, you can see that here on the left side it goes up, on the right side it comes down. If you want to use words to describe, let's turn off that one, sorry. On the left it goes up, so you could say up, down. Because on the left it goes up, on the right side it goes down. For number 3, it's an even degree polynomial with a positive a. So this one is going to go up on both sides, left and right. The domain is all reals because when you go from left to right, there are no gaps, and the arrows indicate that it's going to continue opening, as you go up, as you continue. So the domain is all reals. The range starts at 0 because remember the range is your y. Starts at 0 and goes on up. It includes a 0. And so this one, as x goes to infinity, f of x goes to infinity, and as x goes to negative infinity, f of x still goes to infinity because both ends go up. So you can describe this as up, up. Okay? Number 4, f of x equals negative x to the 8th. This means that, you see the power is even and the a is negative, so this is going to open down. Okay, the domain is all reals. And the range, this time, remember for a range, you go from the bottom to the top. So we start off with negative infinity and stop at 0. Bracket on the 0 because it includes the 0. There's a dot on 0, 0. So for the end behavior, as x goes to infinity, f of x goes to negative infinity, and as x goes to negative infinity, that means as it goes to the left, as you go to the left, f of x continues to go down. So both left side and right side go down. So this could also be described as down, down. Okay, for number 5, remember I told you to do some additional things, not just what it says in the book. So you're going to find the leading term so that we know the end behavior of this polynomial. So I take every x and multiply it together. So x times x times x. Notice the exponents are 1 for each of them, so that's why we're just doing x times x times x. So the leading term is going to be x cubed. So that's going to tell me that this polynomial has if you use the words down and up, on the left side it's going to go down, and on the right side it's going to go up. So it's a down-up polynomial. So as x goes to positive infinity, f of x goes to positive infinity, and as x goes to negative infinity, f of x goes to negative infinity. Okay? So again, on the graph, down up would look like this on the left side, and on the right side it would go up like that. Okay? On the zeros, well, we take a look at every factor. So the first factor right here is the x by itself. So that tells you that the 0 is 0. Multiplicity is 1 because the power of x is 1. So that makes it an odd number. So then that's crossing. Then next up is this factor right here. The 0 for that one is negative 1. The multiplicity is 1, so it's an odd number. And this one also crosses because of the multiplicity being odd. And then the third factor, this one right here, what makes that one 0 is negative 3. The multiplicity is 1 because, again, the power up here, the power here is 1. So that's odd. And so it's crossing. So just a rough sketch would be 1, 2, 3, 4. So I know that the graph intersects the x, or has contact with the x-axis at 0, 0, negative 1, 0, and negative 3, 0. And based on my multiplicity, I know that it's going to cross through each one of those. Another thing, the end behavior, so this right here tells me what's going to happen at the left end and the right end of the function. Okay, so I know that I take the outermost points, the outermost zeros, and I know that on the first one the graph is going to go down, and the second one the graph is going to go up. Okay, so I connect the two ends, the left end and the right end, with a curve. So I know it's going to cross through negative 3, it's going to cross through negative 1, whoops, I missed it a little bit, cross through negative 1, and then go back up through 0. So that's a rough sketch of the function, okay? Okay, so here's the Desmos screen, and I forgot to put the max and min, but it's okay. They're not asking you to give the actual value, they're just asking you to say the number and type. Okay, so if you notice, the ends go up. That's what we have on our graph. And then it's bouncing off here. It's crossing through 1 and it's crossing through 2. Okay, the curves on our sketch are probably off, but that's okay because we just did it just freehand without plugging in any values for x. We just kind of sketched based on the zeros and on the end behaviors, which is the key thing for the lesson. Okay, it's asking to give the number of turning points. So here is 1 turning point, 2 turning points, and 3 turning points. So we got 3 by looking at the graph. And so if we use a formula, n minus 1, the power of this function is 4, right? It's x to the 4th power, so it's 4 minus 1, which gives us 3, which matches what we got on the graph. Okay? And then we have a global max. No, actually we don't have, so this one has no global max, but it does have a global min right here. So this point right here is the global min, which could also be considered local min, and then this is a local min right here, and this up here is the local max. Okay, so the first thing we look for is the leading term. So notice how this is a negative x, and then this is x squared, because after you multiply it out, you are going to end up with an x squared from this factor, right? Because of that 2 right there. So what's a negative x? Negative x times an x squared gives you a negative x cubed. So this one's going to have a an up-down pattern where the left side is going to go up and the right side is going to go down, because this is negative, the a is negative, and the exponent is odd. So if you can check your table if you're not sure, but that's what you get. So as x goes to infinity, f of x goes to negative infinity, and as x goes to negative infinity, f of x goes to infinity. Okay? The zeros, we go right here. So this x is by itself. It's not, there's nothing added or subtracted to it. So if x were 0, then this factor would be 0. So for the first one, we have 0. The multiplicity is 1, and that's an odd number. So that means it's going to cross. For the next factor, this one right here, the 0 is 2. The multiplicity is also 2. That's just a coincidence. And so we know it's going to be tangent, okay, or touch. So we go ahead and draw the, again, simple sketch. 1, 2, 3. So I put 2 right there. And so we sketch the 0, the 2, and you take the outermost points. Like this, there's only 2 here, so there's only 2 to choose from, and that's where you draw your end behavior. Okay, so on the left one, I'm going to go up. On the right one, I'm going to go down. Okay, and then in between, remember, the graph is not going to touch or cross through any other x value other than 0 and 2. So what does the multiplicity tell me right here? That at 0 it's going to cross, and that at 2 it's going to be tangent. So at 0 it's going to cross, and then it's, at some point it's going to turn back up, and then it's going to be tangent. Okay, so it looks something like that. Again, this piece is not too accurate because I'm just doing a rough sketch. Graphing calculator gives you the better picture. But you need to be able to do this part by hand, and then just confirm with the graphing calculator. Okay, so take a look and compare the 2 graphs. The one we drew by hand, and then the one on decimals, pretty close. First thing we're going to do here, though, is look at the turning points. So there's a turning point right here, 1, and there's a turning point right here, 2. So 2 turning points. Well, the degree of this polynomial is 3, right? X cubed. So the formula is x minus 1, n minus 1, so it's 3 minus 1, which is 2, and that's what we got, 2 turning points. This one has a it has a local max right here. Let me just erase this part. It has a local max right here. The value is 0, okay, and it has a local min right here. The value is negative 1.185. It has no global max or min because the ends of this graph go on up forever and down forever. So no local max, no global max, no global min. Okay, so we're going to first figure out what the leading term is, and in this one we have an x right here and an x cubed right here, and y cubed because of this 3. So this is an x cubed and an x, and then there's a negative out here. So this means, let me change the color, negative times x cubed. Now this is not the whole polynomial, but this just gives you the leading term. So this would be negative x to the 4th. Okay, with that we know that the ends of the polynomial both go down. Why? Because the degree is even and the a is negative. Okay, so both go down. So now for the zeros, you take the first factor